everybody. Welcome to another episode of Coffee Hour. My name is Paul Abernathy. I'm your host, as always, on Coffee Hour. You'd like somebody new? Sorry, you get me every morning. So thanks for joining me and taking time out of your day to join me here at Coffee Hour. First thing I'd like to say is thank you all for taking the time out of your day. It's an early start to the day for many of you. Many of you are all the way out in California. Many of you are with me here on the East Coast. It's 8 a.m. Eastern time. So again, you have no idea how I appreciate you joining me here this morning so we can talk code, talk electrical, talk whatever topic you want to talk about, just having a good conversation. And I will do my best to try to answer it. Now, today's topic we are going to be talking about, we're going to look at some code questions. I got my coffee, by the way. I got one of our mugs, okay, from our website. Yes, shameless self-promotion. And today we're going to be talking about grounding and bonding, as I promised, kind of looking at it at a very high level. Of course, you can have any questions, feel free to ask, and we will do that. And we'll answer some questions. We'll spin the wheel of goodness, get some people on the list, yeah, all that good stuff today. So let's do a little intro. Let's welcome some folks to the show here. Let's see here. David, welcome. Good morning. Glad to have you here. Adam says, #win, reminding everybody that if you want to get into today's spin, then you have to do #win. Okay, dude, Adam, look, that sounds like I'm like Alex Trebek on that thing. I'm just like rolling it off the tongue or whatnot. So yeah, David's getting into it. #win. There we go. Tino, good morning. He says, morning to everybody. Good morning, Tino. Adams, let me know here, says, morning, everyone. Let's get some coffee for all of us, or juice, or whatever your beverage of choice may be this early in the morning. Okay. Say Tyler Griffins, good morning, everyone. Okay. Texas. Tyler's out in Texas. Let me take a guess. You're not in Tyler, Texas, are you? Probably not. But getting ready for the residential appliance installers test. Absolutely. There you go. Today, you taking it today? All right. Well, let's give Tyler a little bit of... Everybody say a collective shakes the screen. Everything gets to moving when we do that. You're going to nail it, Tyler. Stay focused. Stay focused. Okay. You'll get it. You'll get it. Let's see here. We got Paul. We got our regulars this morning. Paul, #for the win. Thank you. Now, I'm gonna be totally honest. I'm not sure whether #win works when you put it with other things. I don't know if that works. So remember, always just do a separate #win just to make sure no doubt it locks you in. Just make sure, because I don't even know how it works. I just know that #win, okay? Just make sure we do a separate one. That way you definitely are in it. What we got here? We got Manny. Manny, my Facebook friend. Okay, is also behind the scenes in the TikTok, where we're doing a behind the scenes episode as well. So you can see me. You don't get to see the goodness of the show, but you get to see me there, if that matters. Anybody? There you go. Tino's being a sponge today, going to suck up all that knowledge. There you go. That's what I'm talking about. TJI, thank you for joining. Chatty Chatters, that's right. I'm a little amped up today. I've already had 1 cup of coffee, so I'm good. There's my Manny right there over on YouTube. And Manny's getting in the #win. Terrence Grace. There you go, Terrence. Thanks for joining. Terrence was a Fast Tracks member as well. Nepo, got you set up yesterday. You should have your access to your Fast Tracks tube. Just log back in. Thanks for coming. Let's see here. Beto, thank you. Tyler, no sir. Oh, he's in Kaufman, Texas. All right. Welcome to the show. Edgar's in the house from Cali, up early out in California. Then we got Jonathan also in here from Tennessee. Love me some Tennessee. Probably going to come back to Tennessee for a vacation now that we're back here on the East Coast. Probably going to go back. We love to go to Pigeon Forge and go up into the Smokies. I usually will rent a cabin up in the Smokies for a week. I love it. Love getting up in there. 1 year I do the beach. Can't take the beach, but a little bit. Then 1 year I do a beach. Then 1 year I take me and the wife will go up and stay in a cabin, that type of thing, in the woods, that type of thing. Of course, we're not roughing it. It's a luxury cabin, but but you know what I mean. I'm not roughing anything. Red Dog, I'm too old to rough it now. So what's up, Red Dog? Thank you for joining me. Throw that hashtag win out there. Hashtag win, no space between it, just hashtag and win. Okay. Let's see here. Estrada moved from TikTok or TikTok, TikTok. Move for that to hear. Appreciate you. Appreciate you. There's Tyler. Thanks. I suck at tests. Yeah, a lot of people do. Sixth time. Practice the method that we talk about, 3 waves methods. There's certain things that you're just going to know. Now, maybe you haven't been studying right, so I don't know what program you're using, but make sure you follow the 3-wave method. It means go through and answer the questions you know right away without a doubt. You establish that you know, and then mark the ones electronically that you don't know. And on the second wave, you're focusing on those ones that you marked that you don't know. When you answer it, you untick it and keep going. You're only going to spend about a minute on the first wave answering questions you know. The second wave, about a minute and a half, till you start getting that little anxiety feeling that you're taking too long. Then leave it marked. If you can't answer it, go on to the next question. And then the third wave is going to be all those questions that you have left checked, that type of thing. You shouldn't have any real calculations in the appliance one. Okay, so that type of thing. But focus. Go in there with a method, a study method, and you'll be okay. And there's no shame in the game, my friend. 6 times, no shame in the game. As they always say, once you get it, you got it. So don't give up. In fact, you'll probably appreciate the effort because you've had quite a bit of investment in it now and time. So again, you'll get it. Stay focused. I believe in you. Let's see here. John's hollering at us. Good morning, everyone. Let's learn the NEC. That's what I'm talking about. Okay, let's see here. Tyler says, just started using you 2 weeks ago, and then before that, I was using an online course. Okay. You're with us now, so stay focused with us. There's some videos up on our YouTube channel. We do have this subscription model over on Fast Tracks 2 that has a lot of videos for you there if you're interested in it. Let's see, what else do we have here? Boom. Quick question from Adam. Quick question. Do you have any hoodies from any of your programs we can buy? Just asking, want to advertise that. You mean hoodie? Well, we usually get people frown upon creating hoodies that simply self-promote our courses. Like you'd like to help promote us, and you have no idea how I appreciate that. People frown at it for some reason. In fact, they don't even want us to put our URL on it because they're buying a hoodie. They want it for them to wear, that type of thing. So no, we really don't have anything that promotes the courses, that type of thing, because it seems like people just didn't like it. But we will have the Trade Hog will have its own, and it will promote Trade Hog, that type of thing. We do have some stuff out there that has our URL on it, but nothing for the courses, like for the Fast Tracks courses, that type of thing. Don't really have anything specific, but yeah, it means a lot that you'd want to promote that and help us out. All of you out there that share our courses, that share our stuff, you get something out of it and you're helping us. So we appreciate it. It helps us make sure that we stay around. I got to thinking about that the other day when I was giving a review on something. I got to thinking about it. I'm like, there was some pieces of it I did not like on this thing that I was reviewing. And I thought about it and I said, but I like it. And I don't want it to go away. So if I'll give a negative review that could impact them, that's basically just a knee-jerk reaction type of thing, and it might be something nuanced, but it can affect the company. I'm like, I'm not going to do that. I'm not going to say something negative and affect that company's growth, because the more they stay around, the more that I can utilize them. If they go away, but what's the good of a lifetime warranty, or what's good on anything for something if the company goes out of business? So I got to thinking about that, and I'm like, no, if I got nothing good to say, don't say nothing at all. You know what I'm saying? That's the way that's what I have to say about it. Look at Adam. Adam's my big supporter on this one right here. F the haters. You got that right. Shaking the screen. ATM's throwing out some money. There you go. Thank you. Appreciate you being here. All right. And I see Mike, you in here as well. Guys, let me know where you're from. Shout outs to me. I love hearing from where everybody's at. We're a family here. You come here every morning to relax, have a cup of coffee, and chat about the code. Okay. All right. So what I want to do today is I'm going to open it up to the chat, but I'm going to talk a little bit first, and then we're going to spin the wheel. and then do some code questions. But I want to talk a little bit. We'll start taking a little bit at a time. I want to talk about some topics, grounding and bonding. What's up, Rob? Welcome to the show. Welcome to the show. So let's kind of have just a conversation a little bit, a lesson, conversation. You get to bend the ear of a member of Code Making Panel 5, right? And we can have a conversation about grounding and bonding. And then we'll look at a code question and we'll spin the wheel. But putting all your chats on the screen so everybody can see it and you're listening. So what is grounding and bonding? Well, grounding and bonding are often misunderstood terms, right? They serve two different purposes, but they mutually can go together. For example, grounding is a connection of the electrical system to Earth, okay, creating a reference voltage, okay? So that's when we can take measurements. So when we do 240, we're measuring phase to phase, but we take any one of those phases and measure it to ground, we're measuring 120. The voltage reference to ground is 0. So we're able to get that potential and read it from 0 to the one phase, which is 120, in a 120 240 volt application like that, right? Let's see. I need a FRC. Tell me what FRC shirt is, real quick, just so I know, because maybe I'm not up on my coffee this morning. So that's what we create the reference point, right? So grounding does that. Now, equipment grounding conductors that go from your panel out to the devices and things like that are there to do what? To help clear an overcurrent protected device, right? They carry the fault current that can happen. But you know what? It also does serve, and this is where I think the confusion comes from, because it does serve a grounding, okay? A grounding component as well as a bonding component. Oh, flame retardant shirts. Yeah, we don't have any flame retardant shirts, that type of thing. What's up, Frank, in the house? So grounding can serve multiple roles. So when people see the term equipment grounding conductor and they know that it also serves a bonding role, they think, well, why don't we just name it equipment bonding conductor? Well, it doesn't really need to do that, because it's basically equipment grounding conductor. The definition has a note that reminds us that it serves a bonding function as well. And it's tying all parts together. That's why we tie all equipment grounds together in boxes, right? Creating this network that creates a low impedance path back to the source. Now, this is why when we parallel conductors, right, and we parallel them, we're collectively reducing the impedance. And so that's why we tie it all together. So that's why you come into a junction box and maybe you're bringing 12.2 NM and you're bringing 14.2 NM in there. But yes, all of the equipment grounds go together. You don't isolate out the 12s and the 14s. You don't do that. You tie them all together. Of course, you make sure you use the right type wire nut or binding device that can handle those sizes. But that's what you do, okay? Now, the pigtail that goes over to the device, that only has to be the size of the actual equipment grounding conductor for the circuit that's being energized to that device. Then they think it has to be a 12 over to each device because they're 14s and 12s. No. If I'm bringing 14 gauge to this switch and I'm bringing a 12 gauge to this switch and I bring a 14.2 and a 12.2 into the box and I tie the equipment grounds together, the bonding jumper that goes over to the switch with the 14 gauge only has to be 14. The bonding jumper that goes over to the 12 that's on the 12 gauge that's on the switch, that has to be a 12, okay? A lot of people get that confused, okay? So that's grounding in a nutshell. What's bonding? Bonding is really as simple as ensuring that all metal parts of a system that are at the same electrical potential, right? And that they are reducing the risk of shock because you don't create this difference of potential. For example, when I talked about measuring from 120 volts to the ground, then it created a difference of potential, and that's how the 120 was registered. And that's how you're going to get shocked, right? There's a difference of potential. But if all the metal parts, and it's kind of what we do in pool bonding, where we bring everything around it up to the same potential, then if they're touching two separate points and you don't have a difference of potential, then current can't flow. So we make it safer. Doesn't have to do with the fact that you could create another path that you do get shocked, but what we do is we create this everything is tied together, so it's all at the same electrical potential, then there's no way to have a difference of potential. And that's why when we measure 120, 240, again, we go from one leg to ground. That's why we get 120. We go phase to get phase, we get 240. Okay. So when you think of grounding, think of anchoring a boat to keep it steady. Okay. So think of grounding. You're anchoring a boat to keep it steady, a metaphor, if you will. While bonding ensures that every metal part on the boat is electrically connected. So the boat anchored in place, think of that as your grounding. All the parts that are metal tied together on that boat to make them act as one, that is bonding. Okay, simple concept of bonding. All right, so there we go. Now, let's talk about some main concepts. We have grounding electrode system. That is a system that includes things like ground rods, water pipes, grounds, if you got them, concrete encased electrodes, with UFERs, that type of thing. UFER, people ask, what's a UFER? It's actually just slang for a concrete encased electrode, which was originally, a lot of the testing on the UFER was done by a guy named Herb UFER. And he wasn't the only one. There were also engineers around the country, inspectors, and people like that around the country that also, especially on the West Coast, helped contribute to that. Okay, they helped contribute to the understanding of what a UFER ground was. A UFER ground in itself is not just, for example, rebar or the 4 copper that is 20 feet in the footer. That is not in itself just the rebar or just the copper. It's a collective component, okay? It's a collective thing of not just the rebar, but also in conjunction with the concrete, right? That is in contact with the earth. And concrete stores moisture over time, okay? That scenario, that type of thing. So Tita says, talk about using a pipe as a ground. Now, you're very rarely ever going to use a pipe. It's a 3/4 pipe. You can drive it just like a ground rod and put a fitting on it. But nobody would do that because it's too hard to drive. So I don't think anybody in the country would do that. If you have a water pipe ground that qualifies, 10 foot in contact with the earth outside in the earth, no protective wrap on it, it's a conductive metal, it's in the earth, then that can qualify as an electrode. That's 250.52A1 of the NEC. Very rarely do we see that today. And if you do have a water pipe ground, you're required to supplement it with another type of electrode, A2 through A7 or whatnot. So you have other options because you can't supplement a water pipe with a water pipe. The concept for that is that what happens if something happens to the water pipe and they replace it? Well, you have to have something that stands alone as an electrode if the water pipe is replaced. Right? Makes sense. So very few people do the water pipe as the electrode anymore. Usually the most common would be ground rods, concrete encased electrodes. And all of these, by the way, are in 250.52, A1, 2, 3, 4, 5. You get to see all of them, the different types like plates, rods, pipes, rings, the in-ground steel, things like that. Different types of electrodes. Even have the chemical type that you can get. Okay. Problem with those is that you have to replenish those, that type of thing. Okay. So anyway, so grounding electrode system. And so it's really designed, the grounding electrode system, and there's a lot of misconceptions about what we do with these grounding electrode system, these rods, pipes, plates, and all that. It is not to clear any overcurrent device. Okay. It's not going to work. It's designed to give you that reference point for the earth, and for things outside of the building, it allows for surges, lightnings, and transients to dissipate into the earth. Okay, that type of thing. Okay. So Tino, are you new to the industry? What is the depth of a ground rod? Ground rods, you have to do 8 foot, drive them 8 foot. If you don't reach 25 ohms or less, you have to supplement it with either another ground rod or some other type of electrode. Typically, ground rods are 8 feet long and they have to be driven into the earth. That type of thing. Okay. All right. So that's kind of the grounding electrode system. The next thing people get confused in is, how do I get to that grounding electrode system? How do I get to the electrodes? Well, that would be the use of what's called a grounding electrode conductor. And that grounding electrode conductor is going to extend from the grounded terminal bus in a building, or it could also extend from the equipment grounding terminal bus in a detached structure down to the actual electrode that we just talked about. Okay. So that's one of those things, is really one of the situations where, okay, when I'm going from the panel down to an electrode, that is my GEC. That is making the connection to the earth, up to this system in the building, okay? And so that conductor connects the service panel, if you will, to the electrode. But on a detached structure, if you go to 250.32, for example, in a detached structure where you have to, if you're going to put a panel in there and we're establishing a grounding electrode system there, then you wouldn't go to the grounded conductor in that detached structure. You would take the GEC from the electrodes up to the equipment grounding conductor. Remember, because we have to have that separation downstream of the service. Okay, neutrals and grounds do not go together. That type of thing. Okay, so that's kind of the concept of this. So that's what a grounding electrode conductor is, and that is making that established connection to Earth. But again, it's a kind of one of those things that people will get a lot of confusion over. That's not a equipment grounding conductor. That's not a bonding jumper, supply side bonding jumper. That is a grounding electrode conductor. Now, here's a couple misconceptions that people have, and we'll probably cover these again later, is let's just take ground rods. So let's say I'm going from a panel down to ground rods. Y'all do this all the time. Y'all typically will probably use 250.66A. You'll probably run a 6 copper. You'll run it down to ground rods, right? You'll run it to the first ground rod, and you can't meet 25 ohms or less, so you install a second ground rod. I mean, obviously, if you're installing one ground rod, chances are you're gonna, if you need to, you're gonna install 2 ground rods. You're not gonna use one of the other ones, because if you had a UFR, you wouldn't need to supplement it, right? So, assuming that you're gonna run 2 ground rods, the grounding electrode conductor has to be run unbroken. Now, you have some exception to that where you can CAD weld it if somebody cut it off during construction, like copper thieves. Or you can do irreversible crimp if you want to do that, if something happens and somebody cut it off and left it too short. But generally, it's unbroken. So you go from the panel down to the ground rod. That is your GEC. Now, you have 2 choices here. If you do a second rod, you can continue through and loop it through like an acorn and go to the second rod, which has to be at least 6 feet away, right? Because of what we call the sphere of influence. Now, when you do that, it does not have to be run unbroken. You could stop it at the first rod, put it on a clamp, put a second clamp, and then run what's called a bonding jumper over to the second rod. Okay? People get mind blown about that. They think, no, doesn't the GEC have to be continuous? No, it does to the first electrode. The second one is supplementing the first one because you couldn't prove 25 ohms or less. So people, that's like people don't understand that concept, but that's what you're doing. You're supplementing. 1 rod's all you need unless it can't meet 25 ohms or less, and most people don't test it. So that's why you put a second rod in. Okay? All right, Tyler, my daughter's digging, watching me. I'm not that crazy. I'm funny to look at, I'm sure. Okay, so I am much better also than Barney. Okay, he's purple. I don't know. All right, so next. The next one we talk about is the equipment grounding conductor. And the equipment grounding conductor is a return path for fault current. It helps the breaker or fuse to trip. And when we're going from a panel with our circuits out to whatever the load is. And its sole function, not sole function, it's got multifunction. One, it's to help clear an overcurrent device. But obviously, it's also a bonding component that helps to extend that earth reference throughout the system so that we can get accurate readings when we're taking voltage readings. Because remember, we need that reference to earth if we're going to get any kind of connection to the earth, right? Frank says, how do we test 25 ohms? You need a ground ohm resistance meter. You can't use a regular ohm meter. It's a special meter. Now, they have cheaper, what's called 3 or 4 point fall of potential ones, but you got to have enough room to put these probes in the earth and all that. So most people get the clamp-on type, and they're expensive. You can still find them today, but you probably can get them from anywhere from $800 up to probably $1,500. Now, here's my thing about that. I'm a practical guy. I've been a contractor for years. I ain't spending $1,500 on a damn meter like that. Okay, I'm just being real with you folks. I just as soon get the helper to go drive another ground rod. The ground rods cost me $15 or whatnot. Put that sucker 6 feet away from the other one, and I give him the hammer drill with the attachment, and I say, "Have at it, young buck," and go that route. But if you're doing a lot of things with a lot of towers, cell towers, you're doing things that require engineering to get the impedance, the ground resistance down as low as possible, then these can come in extremely handy, right? Just click it right on and go. So I think it all depends on the work. If the everyday work that I did, residential, commercial, industrial, light work, that type of stuff, I would never buy one. But it's called a ground resistance ohm meter, okay? So they're expensive. Unless you get the 3-point fall of potential ones, and you got to drag out these leads and put them in the earth, and ain't nobody got time for that. So easier for me, drive 2 rods. Now, interesting thing about the 25 ohms thing is that only applies to rod pipe plate type that scenario, okay? So we don't really worry too much about that type of stuff. And actually, I will show you that since we're not a tool, not on my tool list. Absolutely, a little bit expensive. Larry's got one. Larry put that money in for one. All right, but let me show you real quick so you can kind of see in the code what we're talking about for those. Since we got deep into that topic, I think it's nice to go to the code and look at what we're talking about. People can appreciate that. All right, so we're going to go down here. And you remember I was talking about the different types of rods, right? Different things. So there's your metal water pipe. There's your in-ground steel. And that is basically like I-beams driven into the earth or in the earth encased in concrete. That's what those are. 10 feet or more, okay? There's your concrete encased electrode. Notice it doesn't say UFR, but that's slang for what it is. There's our ground rings, and there's your rod pipe or plates, yada, yada, yada. There's the length, there's the sizes, yada, yada, yada. There's the plate rules and that type of thing. So now what I was talking about is this one right here, the grounding electrode system installation, rod, pipe, and plates. See this right here? Okay. So this is down here where it talks about supplemental electrode required. It says a single rod, pipe, or plate electrode shall be supplemented by an additional electrode of the type specified in 250-52A2 through A8. Okay, all right, so let me just explain this real quick. Ain't no damn body going to supplement a ground rod with one of the other types of electrodes. What would be the freaking point? If I'm going to put a rod in, I'm going to supplement it with another rod. So that's just a common sense thing. So I just like to make that clear. It does allow you to supplement it with the other types of electrodes, but why would you do that? If you're putting a rod in anyway, what's the point? Now, somebody might have put in a pipe type of electrode, 3/4 inch pipe electrode, and then you're thinking, well, I could supplement that with the ground rod. Then that makes sense if you want to do that. Because I can tell you, after they tried to put the pipe in the ground, they probably realized, screw that, I'm going to put a rod in. I'm just saying. All right, so there. Now, here's the exception. So read this. It says, if a single rod, pipe, or plate electrode has a resistance to earth of 25 ohms or less, a supplemental electrode shall not be required. That's important language, folks. Why is that important language? That's important language because that pretty much tells us out the gate that we have to do what? And excuse me real quick while I change something here, guys. I'm not liking the way this is looking here. Hold on. You know how I am. When I don't like how something looks, I got to fix it because it drives me crazy. Hold on. I don't like how this looks. Hold on. Y'all know how I am. I do not like when I see something I don't like. Okay, that's better. Sorry about that. Okay, so as I was saying, the rule really is now that you have to supplement rod, pipe, or plates. So years ago, it wasn't like that. Years ago, it was, well, you go with one, and if it doesn't meet 25 ohms or less, you go to two. I'm just using general. Here it says, look, you're going to supplement rod Piper plates unless you can prove that it's 25 ohms or less. If you can't prove it, right, then you have to, so that's the way it's written now, okay? So you have to have, if you're using a rod Piper plate, you're going to supplement it with another electrode unless you can prove that it's 25 ohms or less. And then you got to break out the meter and all that kind of, that type, so what I'm saying? So yeah, so that's what we're talking about with that. All right, so anyway, let's get back to the lesson. Oh, this is a lesson. This is not, oh, where are we at? We got to go here. Dude, I'm all over the place. Okay, so makes sense? Okay, so that's what we're talking about when it comes to that. Real quick, let's go on and spin the wheel of goodness and give somebody something before we get a little more, talk a little bit more, because we got to talk about a little bit more about equipment grounding conductors and a little more about bonding jumpers, and I'll get into some misconceptions and stuff like that. So let's spin the wheel. Let's pick somebody. Make sure you get hashtag win in the chat so you can get a chance to be in the drawing. Hashtag win, folks. I'll give you a second to get something in there really quickly while you got time. What's up, Tyler? Good luck. Hit the road. Let's see here. Frank, I see you, Frank. I got a question, but let's go on and get somebody real quick. So hashtag win, and let's go. No beatbox today, Paul. I embarrass myself when I do the beatbox, bro. What's up, Eric? I saw you sneak in there. Tyler, don't run too soon, Tyler. You got listed in the drawing. You got to see what you got to win. Hold on. I got to get a new list here. Man, the dude was going to run away and leave us, and he's getting ready to win something. What are the odds of that? I can promise you, folks, that was not planned. All right, so let's spin the wheel and see what Tyler's going to win or what he's going to get registered for. Where is DJ Paul? Sorry, I want to do that today. All right. Y'all ever heard my clicking? All right. Tyler, you are registered for the grounding and bonding course that we'll be giving away around and about March 31st. So again, it was important that you stay here and see that. So I'm going to get that down, 2023 G&B course. So you are registered for that drawing. Let's pick another person. Let's get somebody else registered or select the name. Let's go real quick. Hold on for a second. What's going on here? All right, bear with me, folks. I don't know what's going on with my thing here. Hold on. Ooh. Not sure what's going on. My wheel of goodness has disappeared, folks. I have no idea what happened. We're having a malfunction here today in the show. All the chat's gone. All my widgets are gone. There we go. Let's try it again here. All right. I don't know what was going on. We had some malfunctions. It's probably Elon Musk's Tesla or whatever that thing is up in space was giving us some problems. So let's see here. Let's see what we got here. Let's pick somebody else. It's not working. It's always something. It is not working today. Good old... Actually, it's probably EV Mux is probably giving us problems today. Looks like it's probably giving us problems today. So I don't know if there's a problem with the stream or whatnot, but it is definitely not working. All right. So again, so much for that. Let's go look at some lessons real quick. All right. If you're still here, we'll look at the lesson because I don't know what's going on with EV Mux today. As always, just give it to Tino. It's short circuit. It did short circuit. I don't know what's going on with it. Good old EV Musk, my streaming software. All right, here's a question. We'll look at the question real quick, folks. All right, single conductor cable in a cable tray shall be blank AWG or larger and shall be of the type listed and marked on the surface for use in cable trays. So this is when you see that familiar mark CT use or for CT use, or you see those type of things, then you know. So in this one, the key takeaway in the question is going to be what? The key takeaway is the fact that it's in what? A cable tray. So that's one thing that should be your trigger here, is that you're dealing with a cable tray. Now, of course, it's a single conductor cable in a cable tray, all right? And it gives a minimum size requirement. So Tito has 1. Okay, he's got an answer up on the screen. Look it up in the code. So where will we look for this? Okay, so one thing that we would do here is we're going to go look at the code, and we would look under, and I would look under cable tray. All right, Jonathan, take care. Have a great day. And just so you know, you definitely did get your question right. Didn't get, but you definitely got it right. So there you go. Start that day on a high note, that type of thing. Let's see. So if I was going to look at the NEC, then or look at the index, then I would be here. And what I would be looking for is I could go under cable tray if I was looking at the index. But y'all all know that there's an article, right, specifically for cable tray. Somebody throw the article in the chat for those that know. Instead of just the answer, throw the article. Maybe find the answer. That would be great. So I'm going to go back here, and here's cable trays right here. Okay. And when you look at cable trays, we're also looking at and say, so under cable trays, we're looking to see what would have to do with single conductor cables, anything that have to do with being put in a cable tray. Look at John. John throwing up some answers up on the screen here. All right, so let me look real quick here and see what would be under here. It might be relevant to us. Okay, just remember, the key thing is remember what? Cable tray is in the index. Markings. Okay, we see something marking. So I might jot down dot 18 and do some searching, but it's really not germane to the question. Let's see here. We'll go down a little more. Use is permitted. Okay, 392. So this is a permission requirement about being put in a tray. Okay, what's up, Robert? I see you in there. Let's see. Okay, and then you have wiring methods. 392.10a. So it seems to me that my reference is 392 as the article, and it seems like I've got dot 10. I got dot 18. So we'll start at dot 10. And what else? Again, this is how we dissect it using the index. This is what you should be doing. It looks like Terrence has thrown something up in there as well. Appreciate that. And I'm dissecting. Now, also, let's see. What about single conductor cable? Do you think there's anything for that? So let's see here. I'll look under cable since I'm already right here. Here's cables right here. So let's see if there's anything in here about cables, and it says something about here. Okay, here it says cable trays, installations in, see cable trays. We already did that. So that would have sent us there, right there. I'm just seeing if there's anything else. It's always nice to look. This is what we do when we go dissecting. We're just looking to see what's in here, so now we know what is actually under cables. That's what we're trying to do. We're just trying to learn to see what is actually under here. That way it saves us time in the future. Okay. And let's see here. Okay. And when there's our cable tray that we saw. Now, the question is, just for craps and giggles, is there anything under single conductor cable? I just want to look. That way we learn. And let's see here. I'm going to look under... Okay, here we're at under HI. Let's see here. Signal, no. Nope, there's nothing there. So now we learned that there's nothing under that. Okay, but we learned it's 392. Okay, so we're going to go back to the NEC. 392. And that is, obviously, you could go to the index as well. You could have gone to the table of contents as well if you wanted. Now, for those that are new, that have never joined me before, say, well, Paul, you're spending an awful lot of time in the index. Let me make something really clear real quick to those people. For those people that are saying that, you're watching on other different platforms, you're being taught by instructors who don't know what they're doing. When you're learning the code and you're taking your time, and all these guys that are on the screen right here, they know this. For anybody that's new, that's silent in the background, you should take your time. You spend good money for your questions. You need to dissect the hell out of a question. You need to look at every possible trigger word, go to the index, back and forth. That's structured learning. That's what helps you learn what is and what is not in the index, so that in the world, when you're out in the field, you can find the answers quicker. But on an exam, it helps you find the answers quicker and you can learn. Plus, going in and out of it just makes you smarter, that type of thing. So that's why we do that. Now, when you get down to the last 2 weeks before your exam, then you can start timing yourself, and you're not going to dissect because you spent all that time learning how to dissect. And that's what we're doing. That's what we're doing here. Okay. So if I'm back to the NEC, just to go back to it, here I am in NEC. And again, we had .10. This is a uses permitted, right? And here's our wiring methods. And again, here is the application. And this is interesting. So here is your single conductor cables right here, right? And single insulated conductor. You're welcome. That was my submission into the 2023. I'm going to be honest with you. I made a little bit of a lazy mistake. I know what you're thinking. You're thinking, uh-oh, Paul made a mistake? Paul made a mistake? Okay, let me explain what my mistake was. I made an effort. Good morning, Seti. Thanks for joining us. Outdoor Man, thanks for joining us. I made a mistake. When I got this in here for single insulated conductors so that you could have things like THHN, THW-U, XHHW in trays, which you weren't permitted before the 2023, believe it or not, you weren't permitted. And even single insulated conductors, which are not THHNs, XHHWs, that's not single insulated conductors. I mean, that's not single conductor cables. Those are single insulated conductors. When I got this added to the code, and again, you can only put those conductors in an industrial establishment. You can't just put them in any cable tray. It's got to be an industrial establishment. When I did this, I was so pleased at getting this added that I did not think to add this everywhere else in 392 that makes a reference to single conductor cables. It needs to be everywhere. Right? Now, for those out there that say the code making panel should have done it, no, because they don't just go rewriting code. It's what's submitted, and I didn't submit it, and I didn't think about it, and I'm not on that code panel there, so I got screwed. Abraham, that is not correct. Okay, so at the end of the day, that was kind of one of those things where I was like, dude, I realized it. So if you go down here and you'll see on the screen right here under B, industrial establishments, because if you got to read A, it tells you all about, and it tells us right here, it says single insulated conductors and single insulated conductors, or single insulated cables and single insulated conductors shall be permitted in cable trays only when installed in accordance with 392.10b1. So that's the rule, folks, that tells you that single insulated conductors like XHHW, THHN, that type of thing can't be in a cable tray. I know this is going to blow some of you design professionals' minds. It cannot be in a cable tray, right? Unless it meets 392.10b1. And that is what? Industrial establishments. Who determines the industrial establishment? That's going to be AHJ. That's going to be something you need to work with the locality, because that is typically not going to be just a regular commercial environment. Okay, industrial, producing products, those type of things. That is something that people don't understand. They think you can just put regular single insulated conductors in cable trays all the time. That is not true. It has to be an industrial establishment. And then when you do, then it gives you this rule here. And into that rule, it says single conductor cables and single insulated conductors shall be 1/0 and larger, okay, and shall be the type listed and marked for the surface for the use in cable tray, okay? So it is 1/0 and larger is the answer there, okay? So let's get back to the lesson. And so this answer here can only be 1/0. And there's our reference right there. Okay? Makes sense? All right, let's do another question. All right, aluminum fittings and blank shall be permitted to be used with RMC. All right, is it aluminum fittings and blank? Is it aluminum fitting and enclosures? Is it aluminum fittings and conductors? Is it aluminum fittings and conduit? Is it aluminum fittings and conduits? Okay, that type of thing. All right. So think about that. Look at this real quick. I'll give you a few seconds to think about answering this question, and give me some answers on the screen. Give me some code references. Let's go. Let me give you a little bit of time here. All right, I'm not seeing any answers in here. Not seeing anybody. No. Nobody? None? All right, Ray says 344.12. Excuse me. Yeah, 12. He's close. Might be in a different code cycle than we are, so we'll go look here real quick. But that's and Ray says conduit. Okay. All right. Anybody else? Want to look? No? All right. So here's my things, what I'm looking for. So the first key trigger here, folks, is this is rigid metal conduit. And y'all know there's a specific article for rigid metal conduit. So that is something that you should be learning, and that's what you learn in our structured program. And you also know that rigid metal conduit is not a big article, right? It's not a whole lot of detail, 3 parts, things like that. It's all right, Adam. Adam's on the drive. You're listening in. I get it. It's all good. All right. David says conduit. Okay. A lot of people say conduit. Okay. So aluminum fittings and blank shall be permitted to be used with RMC. Okay. Well, to be honest with you, conduit seems too obvious, right? Because obviously aluminum fittings, that seems a little obvious. But one of the things we would look at is we could go look at the index just for craps and giggles. We look on a rigid metal conduit because we know there's an article, and I say bold scan, to be honest with you. But let's go see what the index might give us. So let me go here real quick, and let's go to the index. If we didn't know, we're going to go to the index, and let's see here. We're going to share this tab, and since we're already at S's, we're going to go back up to rigid metal conduit and see what we might get. Just for looking, this is how you learn, folks. Now, if you're in an exam and you already know the answer, move forward. But if y'all had answered this in the exam, you'd be wrong. Okay, I'm just going to tell you right up front, all those that have answered so far, if you just did this on your exam, then you'd be wrong. Okay, and I'm liking Abraham. Is that it? My favorite engineer. I'm liking his response on this one. I'm also liking the barbecue man on this one. Okay. But see, you're so quick to answer, you would have gotten it wrong. So that's just why we do this. All right, so let's go real quick to rigid. All right, so rigid metal, it says C, rigid metal. Okay, so we're going to go find rigid metal. Remember, my eyes aren't the greatest in the world, guys, so bear with me while I'm going through this. I can remember, I'm getting old. Okay, I'm going to die someday. So, we gotta, and there's other people that wish you would come earlier than later, but I got my haters. All right, so here's rigid metal conduit right here. So we know it's 344, okay? And we're just looking construction specifications. We see that type of thing. Let's see here. 344.42, couplings and connectors, dissimilar metals, something similar right there. So this is it's almost like a dissimilar metal situation. We've got aluminum fittings, and it's talking about connections. We're not talking about an aluminum enclosure. We're not talking about conductors, so that eliminates the conductors. Conduit, if you're going to use an aluminum fitting, so again, some of these stuff you're thinking, let me look a little more here. Let's see here. And then the first thing I'm going to notice, guys, that it is 3 permitted uses, 344.10. So it's not a big article. So I'm going to switch to bold scan, and I'm going to look for key trigger words. What's up, Lewis? Thanks for joining us. So let me go back to the NEC, and I will share this one right here. Hold on. Okay, so we're back here at 344. We're going to bold scan it out. So there's the scope. Has nothing to do with dealing with fittings and any of these words that are in the answer. So listing requirements, again, all fittings, couplings, and all that's got to be listed. Yep. Uses permitted. Gotcha. I don't see anything in here. This is just talking about corrosive environments under wet locations, physical, dissimilar metals. Now we see the words fittings, cabinets, boxes, steel, everything. Okay, wait a minute. Let's look in here and see real quick. It says, let's see here. Where practicable, dissimilar metals in contact anywhere in the system shall be avoided to eliminate the possibility of galvanic action. Makes sense. Stainless steel and, here's what we want, aluminum fittings and enclosures shall be permitted to be used with galvanized steel RMC and galvanized steel fittings and enclosures shall be permitted to be used with aluminum RMC. Okay, so this is one of those questions where you have to look at it and go, okay, what is it asking me in this question? All right, so let me get back to the lesson here. So the only real plausible one here is aluminum fittings and enclosures. Only logical one that can be. And 344.14. Again, a little harder type of question, but some of you folks found it and everything like that. So Derek, welcome. Thank you for joining us from Chicago. Anybody new? I say Paul got it. He was like, hell yeah. He got the code reference. He also got enclosures. Okay. And Derek said, good morning. What's the appliance installer test? That's in Texas, where they have licenses for almost every single freaking classification, whether it's masters, journeyman, residential wireman. Dude, it's just a money thing. Like in Virginia, there's only 2 licenses, right? Master and journeyman. In some states, they got all these licenses, and I'm going to be honest with you, no disrespect to Texas. I was there, but it's usually just a money grab. I'm just saying. All right, let's spin the wheel. So if you haven't done the hashtag, then make sure you do. So we're going to get it, see if it's working. It doesn't look like it's still working here. All right, so it's not working. So we're not giving away any goodness today. I can't spin the wheel. It's just not working. I don't know what the deal is today. It's trying. All right, good old EV Mux. Guess we're not giving away any goodies today. The goodies, let's get back to the grounding and bonding, talking about grounding and bonding stuff. Because I guess the wheel's not working. I'm going to have to let them try to figure out what's going on with this here. Bear with me here real quick. Okay, let me go back and trying to see what's going on. Bear with me. Trying to see what's going on with the wheels of goodness here. Not sure what is going on with it. Just not working today. Oh well. So much for that. We'll have to figure that out. So let's get back. Let's get back to talking a little bit, end on a little. Now the chat thing's not even working on this widget right here. So I don't even know what's going on. So it's definitely their widgets aren't working today. So it is what it is, folks. So let me get back to let's just talk me here. Let's see here. Widgets aren't working. Okay, so let's end up on some grounding and bonding additional stuff to talk about. Okay, so we ended up earlier and we were talking about equipment grounding conductors, okay? Now the sizing of an equipment grounding conductor, that's from your, let's say from your panel out to whatever your receptacles or the switches, it goes to luminaires and stuff like that. The equipment grounding conductor is sized based on the overcurrent protected device that's ahead of it, okay? So that is one of those things that are like, okay, we're going to use, what table do we use for that? 250.122. And that's what we're going to use. Now, it serves multiple roles. One, fault current, right? The sizing lot of current that gets rushed at a momentary notice, okay, really high. And the lower that we can to reduce the impedance of that circuit, the quicker the breaker or fuse will blow. So that is different. Now, does it serve a bonding role? Absolutely it does. It goes out and bonds all the metal part, everything together as well. Now, we always want to make sure that we remember that table, 250-122. The next one we're talking about is bonding jumpers. Now, bonding jumpers is a very broad term because it basically is used to bond parts together. Whether you're going from equipment grounds that come together, let's say in a junction box, and you're going to do a bonding jumper over two. And also, I've got a question somebody asked. Gotta make sure I answer it. Hold on here. Let me go back and see where it was. I want to make sure they did. I did see it. Here we go. Nepo, if you're still here, I will answer your question before we leave. So bonding jumpers tie metal parts together. So remember that analogy that I gave you about the grounding electrode conductor that goes to the rod, to a ground rod? That is your grounding electrode conductor. Now, the jumper that goes from that one rod to the other rod, that's a bonding jumper. It's extending the connection from the one rod to the other, connecting them together. And the code says when you bring them together, they act as one. So that's an example of a bonding jumper. We have supply side bonding jumpers and we have load side bonding jumpers. All of these are covered in 250-102C and D. C is for the supply side. D is for the load side. Okay, so that brings me into Nepo's question. He says, now in the scenario where a service entrance conductors are in a trough, so they're maybe coming down from an overhead drop, they come down, they come into a trough, and then he's going to branch out of that to different service panels. You can have up to 6 grouped in one location, right? 230.70A1 and A2 and all that good stuff. It says and 230.72 for the grouping and all that kind of stuff in your code book. If you have and it's coming down and it says, then it taps to 4 separate panels and main breakers, what is the proper way to handle bonding in this case? So if you're talking about bonding, the easiest thing to do is to use the grounded conductor to bond all metal parts on the supply side, if that's what you're talking about. So you get the allowance to do, oh, hold on for a second, I'm about to get dropped off of TikTok. The way to do that is to simply take your grounded conductors that come into the wireway, bring it to a lug that's connected to the enclosure, bring your grounded conductors into that lug, and then maybe multiple lugs, okay, like a bar, and then come off of that and go to your panels, okay, and come off of that and bond to it will usually, if you mount it to the wireway, it's going to be all connected. So you can use your grounded conductor, and that is 250-142 to do that, okay? Another way to do that is obviously making sure you follow all of the bonding requirements in 250.92. So make sure you took it 250.92 because you have those different types of methods to do what's a little more called assured bonding, that type of thing. So you can't use standard lock nuts, okay? You have to do something a little more when it comes to bonding. We have a video over on Fast Track's Tube that talks about supply side bonding and how to do it and how to size it. So Nepo, you have just, I believe you got a subscription to Fast Track's Tube. You won that last time. So you get to go and watch that video. Okay. So all you do is in the search, put up in the search over on Fast Track's Tube, put in service bonding or services or whatever, and you'll get the videos for that. And there's a very in-depth video that explains, okay, scenario. Let's see here. What is... Oh, Paul gives us again. Yep, 250-102C1. And that is going to give you the sizing requirements, minimum sizing requirements on the supply side. And then, of course, you have load side requirements. But more specifically, the question was maybe how he bond that trough, that scenario, okay? So one way you also could do it is when you come from your service, come down into your trough, and then you go with nipples, let's say, down into your separate panels, that you're going to use bonding lock nuts that actually are designed to drive into it, as long as you have no concentric or eccentric knockouts. Okay. that type of thing. And so then down in the panels, you could run separate supply side bonding jumpers to each raceway from the panel, and do it that way. And so they all act as one. And so it's bonded by virtue of that supply side bonding jumper coming down to the grounded conductor. Many ways to do it. Okay. Many ways to do it. So, TJI, it probably did Fast Tracks Tube. It probably timed out over there because I'm over an hour. But I think the problem is the reason for that. Let me point this out. The reason that is, remember none of the widgets are working? So I think something's going on with the EV Mux. That's why it timed out. So they're having a problem with streaming it. That's why my widgets aren't working. That's why my contest wheel's not working. So they're having some kind of issue today. Now, I've been with them for probably 2 years now, and they very rarely have issues. So I'm going to cut them a break today. But that's probably why it's out, is because the widgets aren't working, and that would make sense. Okay. And I will double check that real quick. Yep, see it's not working. See nothing's spinning. So that tells me that their system is having an issue. So nothing's going to work for that. So we got to do without giveaways today. Sorry about that, everybody. No giveaways today. Okay, got no wheel to spin. Okay. All right. So anyway, that's going to be it for today. I just wanted to talk about some key components, key misconceptions about grounding and bonding. Let's end on some misconceptions. Number one, people think that, for example, in a temporary pole, one of the look at that. I love this guy. Not here for the giveaways anyway. Is here to learn. That's what I'm talking about. Appreciate you, bro. So, misconception, temporary poles. People think that if you're going to use ground rods, they think you only put one ground rod. And that's okay. Now, maybe your jurisdiction okays that, right? But the reality is, whether it's a temporary pole and it's a service for a job site, or it's permanently on a house, it's irrelevant. The code says if you go to 590, the 590 is going to end up sending you back to what? Going to end up sending you back to chapters 1 through 4. So it means that even if a jurisdiction allows you to only put one ground rod at a temporary pole, it's still against the NEC. That might be something they allow, but it's against the NEC because you're supposed to treat that service as a service. There's no exception to this. So you would need to follow the same requirements for the grounding electrode system at that temporary pole. I know some people disagree with that, and that's okay to disagree, but you don't understand lightning and you don't understand transients, and it's the same amount of putting 10 pounds of crap in a 5-pound bag. We have to make sure it's adequate to dissipate that voltage. And what could happen? High power lines falling on low power lines in a storm, and it transfers it down into your drop that may be coming down to your temporary pole or something like that, or your lateral. Still got to be it. So there's a misconception. Somebody think, well, I only need one ground rod at a temporary pole. But if you don't agree to that, or you think that's the rule, then you need to submit something to the code panel because the code panel disagrees. The physics disagree. Okay. So again, treat it like you would a regular service. So now, if your jurisdiction lets you get away, my brother does this. He puts one ground rod and waits to see if the inspector says anything because he doesn't want to drive a second one. That's up to him. I tell him that's up to you. But I just want you to know the code. The other thing that common mistakes that people do is they forget bonding jumpers. Okay, so the missing bonding connections can lead to dangerous voltage potentials and metal parts that are isolated, and that can cause you to have difference of potential, and that's where a person can get harmed, that type of thing. So one of the big mistakes I see is people don't size bonding jumpers right. They realize that the bonding jumpers can be different whether it's on the supply side or the load side. Okay, so that is one of those type of things. The next big not misconception, but common mistake that I find from people is the undersizing of conductors. They simply don't understand the tables in the code and how to size these jumpers, and they haven't watched any of my videos. I've got 3 amazing videos that talk about sizing equipment grounding conductors, bonding jumpers, and grounding electrode conductors. Over on Fast Tracks Tube, Those are some of the better videos that we have, and they've been around for a while, that type of thing, okay? And the other biggest one, the biggest, without a doubt, I don't have a drum roll. I need to add drum rolls here. The biggest mistake that I see still today is people don't understand that when you get to a remote distribution panel, whether it's in your basement or it's in a garage, that you have to have a separation of grounded conductors and equipment grounds. It has to be separated. You do not want equipment grounds to be in contact with the grounded neutral conductor. Okay, so that separation. Probably the biggest one that I see, even today on social media, people will post pictures and they leave the green screw in there on a remote distribution panel. And then they want me to go, well, why are you leaving the screw? Well, it's not all the way screwed in. Then why the hell is it there? Take it out. You know what I'm saying? I'm just saying it's ripe for people to screw that sucker in and screw things away. Okay. So some of the key takeaways today: very high level grounding and bonding. Grounding protects against high voltage surges like lightning and utility faults and high power to low power. That's what grounding does. Bonding keeps all metal parts at the same voltage potential, and it decreases the potential for shock. Okay. And the 2023 NEC made grounding and bonding a little easier to understand, right? And the new structure that'll come in 2029 will probably make it even better. 2026, still going to be the way it is, but it's still pretty good, that type of thing. So hopefully that's a very high level. So if you got any comments, I will entertain them before we go anywhere. I'll just entertain some of them. Tino says, I've had a customer get shocked by the metal siding on their house due to improper grounding. Absolutely. And one of the biggest things that I find that people can make a mistake when grounding and bonding, here you go, check this one out. This is cool. One of the biggest mistakes with grounding and bonding is people are so hypersensitive and in it, and it's such a difficult topic that sometimes people go too far. So it's like you can ground and bond things and follow the code. And this is where people say the code is a minimum standard and they hate to follow the minimum. I'll go above the minimum. This is a classic example where people can go too far, thinking they have to do too much, and they can create a problem. Instead of, they'll actually create a hazard going too far, that type of scenario. So we don't want to create a hazard. That's why we follow the National Electrical Code. It's a minimum standard. Now, going above the minimum is a total between you and your customer if you want to do more. But as long as you follow the minimum, especially with grounding and bonding, a lot has gone into grounding and bonding, okay? This has been around for a long time. So following the NEC's 250 is going to ensure that you have a minimally safest structure that you can get. And this is where people make a mistake. They go too far and then they create a hazard, okay? So establish it first and just think about it before you go bonding all kinds of stuff. You don't know what you're doing. You know what I'm saying? So that was, people can tend to go too far. Tyler, you're most welcome. Yes, let's see. Yeah, somebody else will screw it for you later. After you leave. Absolutely, they will. They definitely will. And Nifo says, I'll check out the videos on Fast Tracks Tube. You are most welcome. We got more and more videos coming. We got in the field videos that are coming. It's a little cold right now. I've been telling you people we got new videos coming on Tube in the field, me scrapping on some tools and doing some demonstrations on certain things. It's coming. It's just too damn cold right now in Virginia. I am too old for that crap. I'm not going out there and make videos for you guys in 20 degrees. Sorry, I love you, but I ain't doing it. Sorry. I'll beatbox for you, but I ain't going out there in the cold 20 degrees to do that kind of crap. I'm just saying. Let's see here. James, what's up, James? Thanks for joining. Engineering support doesn't understand this either. Yeah, so sadly, a lot of engineers, I had somebody ask me this the other day, for our engineers in the room. Obviously, I have a master's in engineering, journeyman engineer, a bachelor's in engineering, as well as a bachelor's in business management. Useless. When I went through my schooling years ago, I did a residency, a minimum residency, and you would be surprised, they don't teach the NEC anymore, or any really ever did in engineering. So they teach basics and we teach fundamentals, and we learn the fundamentals and things like that, different formulas, Kirchhoff's laws and things like that. We learn those type of things mechanical principles, and all that. We really don't do the NEC. So a lot of engineers today literally struggle with the NEC. And it's not their fault. They weren't introduced. That's not what engineering school's about. And so they're learning the engineering fundamentals of electricity and the circuitry and that type of thing. They don't really learn. Now, I wish they would have a whole semester on the NEC. And I'd love for them to have my course and teach them. I used to teach that at a university, but it was an elective. It wasn't a requirement. Now, some engineers who go through engineering school can choose an NEC course as an elective if they want, and they all should if they're going to go into electrical engineering, not electronic engineering. But again, that's why we struggle sometimes with the engineers, because again, they're just like anybody else. They're not experts. Just because they got the PE behind their name or their EE does not make them an NEC expert. You know what I'm saying? So I consult for a lot of engineering firms, that type of thing. So, and let's see here. Tino says, keep track of what you do on paper because insurance will find you and take pride in your work. Absolutely. I tell you today that don't be afraid of somebody looking over your shoulder, because they will be. Just make sure you always keep in your mind, what would Paul do? There you go. I think of what would Jesus do, but for you guys out in the field, think, what would Paul do? And Paul's always going to follow the National Electrical Code. I can hear that now. Every show moving forward is going to be, what would Paul do? WWPD. I can hear it now. All right, let's see here. Larry, or are you going to hear me in your mind when you go to do something? You're going to hear me, okay? And look, Larry's over on Fast Track's Tube, so it must be still up. It says, said most inspector had trouble with this area also. Yes, because there's typically a lot of cases it's not a requirement to be an electrician prior to becoming an electrical inspector. But I wish all electrical inspectors would take a course or take some kind of training. We have a Mastering the NEC course. I wish they would take it to learn the NEC a little bit better. Or at least do me a favor, folks, before we go. Get this one. Get the Hog. Get Fast Tracks. Get Trade Hog. If y'all haven't tried Trade Hog yet, try it out, please. It is a freaking amazing. Okay, I did it walking around asking it code questions in my house and different things like sealing of the toilet, spacing for receptacles, lighting outlets, and it was 100% accurate every time. Having that in the field is going to be amazing for people because it's going to give you answers. And here's how I tested it. And we're starting next week. We're going to be looking at some questions from Nika. And I tested their questions of the day in the Trade Hog. And guess what? Trade Hog nailed it. And it gave some other insights. So we're going to be introducing those questions of the days next week as well. So it's, so there you go. TGI says it came back. So interesting enough. Let's see if the quizzes came back real quick. Nope. Quizzes hadn't come back. Just wanted to check. We're still having issues with the quizzes modules. Okay, well, sorry about that. We'll do extra giveaways tomorrow if I can get it working. All right, folks, went a little over today. Hopefully you got something out of today's episode. Went all over the place. It gets like that when my stuff's not working. But join me every morning, Monday mornings at 9:30 a.m. Eastern Time, Tuesday through Friday, 8 a.m. Eastern Time. I appreciate you all taking the time out of your day. I hope you did. Yeah, Charlie says, update the plugin. The problem is, Charlie, I'm live. And if I try to update that, it could crash it. And I'm so close to the end of the show here, I don't want to crash it. You know what I'm saying? Okay, so everybody, appreciate you. We'll catch you on another episode of Coffee Hour. Join us in the morning. We're going to have a good show, and we'll catch you then. Until next time, folks, stay safe. God bless. All right, TikTok, that's behind the scenes. I don't know why.